現在の天文研究で注目されている太陽系の新惑星候補天体プラネットナイン。前回はこの天体探索の基礎知識として後藤さんのグループが行う探索方法のアイデアを紹介しました。今回はいよいよ最先端の論文の内容について解説を行います。
Okay, thanks. Then finally, we can go to your own study. Yeah. Could you introduce your latest study about the Planet Nine?
Yeah.
Your published paper.
So in our recent work, we use two far-infrared postcard survey, which are IRAS and Artery. So the idea is we search for moving object that first detected in IRAS position, and then after 23 years, it's moved to another artery position. So that's why we come up with the idea of using the combination of two far-infrared spectrum instead of only one.
In the 23 years between two observations,
Yes.
the Planet Nine is expected to move
Yes.
In some extent.
Yeah.
And you found a candidate which moved on the one position to the other position. Yeah, following this two observation.
So actually, the Planet 9, we expect that Planet 9 was first detected in IRAS in 1983, and after 23 years, moved slowly to another artery system detected in 2006. Yes. And the data we use, instead of using the public data like artery price source catalog, we use another dedicated source for Planet search. It's called artery monthly unconfirmed sources because
Unconfirmed
sources. Yeah, because our target is a planet, so this is a moving source. But in artery price source catalog, they only contain the stationary source. So this is not suitable to search for Planet using the archive data. So that's why we use this the artery monthly unconfirmed sources or MUSL. So and our advantage is because there are two collaborators. They are the member of artery mission. My supervisor is also a member of artery mission. So we have the access to the data. That's why we can use the artery data to search for that along with the IRAS data. Yeah.
How many sources there are cataloging, and how did you constrain these sources into one or just one candidate?
So the total source number of IRAS and artery is almost 2.3 million sources.
3 million.
Yes, and we first remove the stationary source and also too bright to our assumption for Planet and then after that we exclude the region of galactic planet and galactic bulge because we expect that these two regions will affect to the flux measurement. So this is not good to consider. But if Planet 9 located in a region, so unfortunately this Planet 9 in this research. And then we search for the moving object from IRAS to artery. We first need to make sure all of our sources above the detection limit of IRAS and artery. Then we create a candidate pair. Each pair includes one IRAS source and one artery source. And then after that, we go to the visual image inspection to see if are there any like galactic cirrus region in the image, or like the iris after 23 years is still in the same position? If after 23 years we still see the iris at same position, then that should be disproven.
What's the pair of the IR source and the library source? How did you identify one source corresponds to the same source in the other source?
So first of all, we estimate the expected angular separation between iris and library based on our searching distance range. So we first determine the range, like 500 to 700 AU, and then we calculate the angular separation range, which is 42 to 70 arc-minute. And for each iris source, we search within that area to find all possible arc-minute source within that area, and we just check the image to see how many groups can left. Yeah.
Oh, I see. So you use mainly use angular separation.
Yes.
In the alkalis observation, what is the wavelength of alkali?
There actually have 4 different wavelengths: 65, 90, 140, and 160 micrometer. But in our research, we only use two bands, 65 and 90, because they are more sensitive compared to other bands. And for the iris, we use 60 micrometer, 100.
I see. So of course, it is the infrared, and I'm from a cosmic microwave background, and I'm rather familiar with the frequency and rather complex. So let me translate it into the frequency.
3
terahertz. Yeah.
3 terahertz.
Okay. I imagine that some emission from a stellar body depends on its property, its material or the temperature of the surface. Does it so vary the temperature?
Because every characteristic of planet nine is uncertain, so we assume that the mass of planet nine is ranging between 7 Earth mass to 17. So 17 Earth mass is actually the mass of Neptune. So we search in this range because if we go lower than 7 Earth mass, if the source will be lower than the detection limit of our planetary, so we can go lower than 7 Earth mass. And for the temperature, we assume it should be around 40 to 50 Kelvin. Yeah. And then we calculate the spectral gradient using the black body radiation consumption for planet 9, and we have the expected flux ranging between 0.2 to 0.6 C.
So temperature is 40 to 50 Kelvin. Oh, I see. So it is almost covered with ice. Or
with ice giant like Neptune or Venus.
This assumption obtained from the previous observation or some theoretical prediction?
Yes, we obtained that result from the previous simulation, which is one et al. 2016. Yes.
That simulation assumes the Neptune-like property.
Actually, they assume that planet 9 should have density similar to Uranus and Neptune. So we use the average value of number, and then we derive the mass, the radius, and then the